We're going to look for solutions to the equation 4a plus 3 is equal to b squared plus c squared, where a, b and c are integers. So the first thing to notice is that the left hand side, so no matter what a is, this side is odd, okay? That's because 4a is even, plus 3 is always going to be an odd number. And then what we're going to do is consider different cases of values of b and c and look for solutions in these various regions. So if we look at case 1, and that's b and c are both even. So that means that b can be written in the form 2m, say, and c can be written in the form 2n, and we have m and n are in the integers. So substituting that in here, we're going to get b squared is 2m squared plus c squared, so 2n squared. That's going to be 4m squared plus 4n squared, and hopefully you can see this is even. So there's no solutions here, because if one side of the equation's odd and the other side's even, they obviously can't be equal to each other. So what's the second case? Well, I'm going to consider b and c odd. So now we have b is equal to 2m plus 1, c is equal to 2n plus 1. So now let's consider b squared plus c squared. We get 2m plus 1 squared plus 2n plus 1 squared. That's going to be 4m squared plus 4m plus 1 plus 4n squared plus 4n plus 1. That is equal to 4m squared plus m plus n squared plus n plus 2. This bit's even, this bit's even. So again, the right hand side's even, so there's no solutions in this region. The final case is, say, b even, c odd. And you might think, what about the other case where b's odd and c's even? But because of the symmetry of this right hand side, b squared and c squared play the same role. So if we check this case, we've checked that other case as well. The case is just one of them being even and the other one being odd. No difference between this case and the case where b is odd and c is even. So in this case we have b is equal to 2m, c is equal to 2n plus 1. So let's see what we get here. We get that we have 4m squared plus 4n squared plus 4n plus 1. Now this is odd. Okay, so this is odd, so we can set this equal to 4a plus 3 and look for some solutions. So if we subtract 1 from both, we subtract 3 from both sides, sorry, factor out this 4, so we get 4m squared plus 4n squared plus, sorry, not this 4 here, plus n, and then on the outside we have a minus 2, okay, subtracting that 3 from here, and that's equal to 4a. So now if I divide both sides by 4, this goes, and now the problem is this becomes a half. So now this is an integer, okay, so is this, but this is not an integer, okay, so this is not in Z. So there's obviously no solutions here. We can't have an integer subtract something that's not an integer and get an integer. So again, we have no solutions. So if there's no solutions in any of the regions that are possible, we therefore have no solutions in the integers for this equation.